I know not just here in the United States, but globally to that point of one-to-many operations. And of course, beyond visual line of sight remains a challenge. And autonomy, as we all know, is key to that. So tell us about your product. It's called WonderLand. And I think we have a really cool video. So walk us through what we're seeing here.
So that's a great video to explain the first product of the company. We divided the visual awareness of our solution to two parts: one vertically autonomy and one horizontal autonomy. WonderLand is basically a software that utilizes a stereoscopic camera pointing down and completely prove the vertical part or vertical autonomy of the use cases, both precision landing, vertical awareness, low altitude mission, and contingency plan. We are doing that by complete understanding of the surrounding, or creating on board, without a man in the loop, a digital twin of the area, and evaluating both the ground risk and the air risk between the platform and the landing point or the mission point, and taking decision based on our very sophisticated logic on board the air, and helping the operator or the mission commander be completely available for other part of the mission.
That was a great video because you could really see WonderLand in action from that vertical standpoint. And I think you also have, as you said, that horizontal obstacle avoidance. So tell us about that.
Well, the video that is running right now, it's still on the vertical part.
Oh, got you. Okay.
And this is a great way to explain how the software analyze both according to a policy that we are providing or setting up in our first software initialization, according with the platform service provider, according to the size of this of the platform and the safety around it, what kind of obstacle it needs to detect, what kind of use case, and what kind of a guidance, a safe guidance to either a contingency, unplanned, uncharted area, or a planned place to be landed. This is not only a robust precision landing, this is also a pure understanding of the vertical distance between the package, if it's winch recovery or not, to the deployed place. I think WonderLand as a first penetration product is very focused on the vertical because we are me and my partners and the team have a lot of experience in the market, and we just met the industry and listened to what they need right now, not only to make the system more safe, also to complete the mission with less people. And this is why we were first focused on the vertical part. The horizontal part, I think we have a few challenges in the horizontal part, and I will be happy to talk maybe further in the call with the video.
Yeah, let's do that momentarily, but I just want to highlight a couple things. So this is autonomous. I saw that precision landing on basically kind of like a drone mailbox. And then that second video was the emergency landing. And what I loved about it, just having gotten my drone pilot's license, was it was highlighting, hey, these are red areas. Like you shouldn't fly, you shouldn't land here. There's like pipes here or wires, whatever those were. And I could visually not only see the red, but then see them as well. So that's pretty significant.
That's exactly the point. We don't see loss of GPS, loss of communication, or other dozen different malfunction as a critical malfunction on board that needs to pop up the parachute or terminate the flight or even to cause an emergency landing. Those type of situations can have a very reliable, a very safe autonomous contingency plan by WonderLand, and in fact replace a visual observer or a pilot, a BVLOS pilot, in the time of the malfunction or the time of the loss of the GPS. So a service provider loves those WonderLand because it's solved. The alternative is sometimes when they lose their unreliable C2 based on LTE or the GPS based on receiving the satellite. The other contingency plan is to pop the parachute, and that's a terminate fatal step.
Yeah, or return to home, which could be kind of crazy depending on what that looks like too, right? Because I just remember we were practicing that with a particular drone in my class, and it depends on the settings you created, right? How high. Once it returns to home, it stops what it's doing. It flies up usually. Whoever knows how high, which may not be high enough depending on where you are, and then it returns to that whatever waypoint you gave it. And the example they gave, and this is multi domains operations support month, right? Or the example they gave is you can fly a drone from a ship or a boat. That's legitimate in the United States under Part 107, even if it's moving. But so many people forget to put that landing point somewhere on land for the home button, and this thing's going to drop somewhere, like wherever you started your boat. It could be dropping right into the lake or the ocean or wherever. So no, that's really significant. I want to geek out for a minute here, Or, because there's folks out there that really want to understand, well, how does this work as a practical matter? I don't want to get uber scientific and lose people, although I'm sure we've got engineers that will understand completely whatever you say. But just kind of in layman's terms, like, how does your vision-based system actually work? How does it read those surroundings and interpret them and autonomously, kind of almost make decisions, if you will, of this is the best place to land?
So this is an excellent question. So our software is working with a vision-based stereoscopic camera that combines, basically imitate the vision eye. We utilize both 2D image processing for relatively long range, for up to 100 meters, and depth perception for high resolution depth obstacles below a certain altitude. In this way, we redundant and create a very sophisticated image processing based on a deterministic algorithm that you can predict and in the future also regulate and replica the human vision for detect and avoid, for obstacle detection and obstacle avoidance based on phases of the vertical approach. So the 2D image processing is improving dramatically our ability to oversee obstacles and objects on the ground from high altitude, but the 3D point cloud analytics allow us to detect very small obstacles like power lines and
Wow.
uncharted obstacles like trees and fleas, and dynamic obstacles like people and animals that very expensive mapping that usually is a prerequisite for mission planning and so on, are not required, and most likely are very expensive to have, and also are not contain this information for example, trees that wasn't there before. People that going into the drop zone or to the low altitude, the close to ground mission, those type of 3D obstacles are easily detected by our stereoscopic image processing point cloud gathering.